Okay, here's another example. We need to factor and then reduce. Common factor of x first. So x squared plus 6x plus 9. In the bottom, x squared minus 9. Hey, those all factor again. This one, all right, let's do the top. So I still have my x, and that factors into two parentheses, x plus 3, x plus 3. All right, what about the bottom? X plus 3, x minus 3. Do you see what can reduce? How about the x plus 3? How about the x? Final answer, right there. Can I grow? All right, let's rewrite this. X plus 3 over x minus 3. Keep the parentheses. Are the parentheses exactly the same? No reducing then. I can't reduce the x with the x. Don't even think about it. Okay, here's another example. Again, factor. Let's do the top first. Difference of two squares, x minus y, x plus y. How about the bottom? Let's go, there's three parts, so let's go with two parentheses. X times x is x squared, all pluses. So how about plus 2y and plus y? Let's do a little check for the middle here. 2y times x, 2xy, x times y, xy adds up to 3. So it checks. Can I reduce? Right there. Final answer? X minus y over x plus 2y. The danger of leaving your answer like this, you might want to cross out those x's. You cannot. I like you to put a parenthesis. Remember my rule, Duran rule, parentheses on the top and the bottom of a fraction. Can only reduce if something's factored. There we go. All right, now we have another type of problem that you're going to have to deal with. F of x equals this fractional expression, 2x squared minus 7x plus 3 over x cubed plus x squared minus 2x. Part A, find the domain of f. Part B, find the zeros of f. So, to do part A, the domain, D, here's a helpful hint to remember this, D stands for down. So domain, you have to take the bottom of the fraction and solve it. Find out what values make the bottom of the fraction 0, because those would be the only values that are not allowed in terms of the domain of f. So if we take the bottom of the fraction and I factor it, I can factor x out first, common factor, x squared plus x minus 2. Then I can factor this part some more. All right, you thinking of the factors for the x squared? That's a no-brainer. Okay, for minus 2. Two choices here. I could use x minus 2 plus 1. I could use x plus 2 minus 1. Which one's going to work? I need a plus 1 in the middle. Okay, this one doesn't work. So, now that I have the bottom factored, here's all three parts. I'm finding the domain, so I have to set them equal to 0. So x equals 0. When I solve this one, I get x equals negative 2. When I solve this one, I get x equals 1. So the domain of this function is x not equal to 0, x not equal to negative 2, and x not equal to 1. Domain. All right? Those values would make the bottom of the fraction 0. So x can be any value except 0, negative 2, and 1. All right, find the zeros. That is pretty easy too. All you have to do is take the top of the fraction and set that equal to 0 and solve it. So let's try that. Find the zeros. So find the zeros, you use the top. So let's take the top. 2x squared minus 7x plus 3 is 0 in the top of the fraction, makes the whole fraction 0. So find the zeros, use the top of the fraction, and let's factor. So 2x and x, and I can use plus 3 or minus 3. What do you think? Notice the middle of minus, so let's do 2x minus 3 minus 1. Another way to try this one is 2x minus 1 and x minus 3. Notice I have to try it both ways to make sure I can get negative 7 in the middle. Let's test this one. Minus 3x minus 2x, that adds up to 5. Doesn't look good. Here, minus x. Oh, 2 times 3 minus 6x. That one works. All right, so there's our bottom. There's our top. So now I have to solve these. 2x minus 1 equals 0. 2x equals 1. X equals 1/2. X minus 3 equals 0. X equals 3. So the zeros are x equals 1/2, x equals 3. There. So I've solved the expression by finding the domain and the zeros of the expression. Just to review, domain, d for domain, d for down. Use the bottom part of the fraction for the domain. There we go. Also in this section, some of the factoring gets pretty difficult, so I want to review some of the harder types of factoring. In number 36, you'll notice this problem has 4 parts. That's a clue that I need to do grouping by factoring. And remember, I could group by 2 or group by 3. So let's try group by 2. First, this is a difference of 2 squares, x minus y, x plus y. This has a common factor of 4. So let's take a 4 out, and I get minus x plus y. Still don't see a common factor, so now I have this group and this group. If that was x minus y, I'd have a common factor. Remember the minus 1 trick? Minus 1 here, you have to use 2, and a minus 1 here. Minus 1 times minus 1 is 1. I didn't change it, I just made it look different. Getting ready for Halloween here. Okay, x minus y, x plus y. That was my first group. And I did my little trick here, minus 4. Now this is x minus y. Now, you stand back, look at my 2 groups. Do they have something in common? They both have an x minus y, so let's factor that out, x minus y. When I factor that out, what's left? Get rid of the x minus y. I have x plus y minus 4. And that's it. I like to make this look a little neater, so rewrite the first one, x minus y, and rewrite this one, x plus y minus 4. All right, so here's another of the harder types of factoring. So let's do group by 2's again. This is 4 parts. But I notice when I group them, there's nothing in common with either of these or either of these. Sometimes you have to rearrange the numbers before you group them. So how about ax minus bx plus by minus ay. Now we got something going. Both of these have an x, so x, a minus b. Both of these have a y, so plus y, b minus a. Oh man, I got to do that minus 1 trick again. Look, that's backwards of this. So minus 1 here, minus 1 here. Let's rewrite it. X, a minus b, minus y, a minus b. Now, common factor, a minus b. Take it out, a minus b. What's left? X minus y. And that one's done. All right, here we go with another one. Again, this one has 4 parts. So, could I group by 2's? Doesn't look good. X squared, y squared, this has an xy, so I'm going to try something fancy here. Watch this. X squared minus 2xy plus y squared minus z squared. I got a group of 3 that factors. I hope you notice that that's a perfect square trinomial, so it factors into a binomial squared. It factors into x minus y times x minus y. I'm going to write it this way. Now you'll notice I have a difference of 2 squares. This is a perfect square. This is a perfect square. That calls for brackets. All right, bracket the problem. factors of the z squared are easy, so I do that first. Minus z plus z. Hey, factors of that are easy. X minus y times x minus y. All right, there we go. Let's just rewrite it. X minus y minus z, x minus y plus z. And that was a nice example of a factor by grouping by threes. One other tricky example from number 42. This one, the exponents aren't numbers but are variables. Still, set up your two parentheses to factor. X to the 2n is really x to the n times x to the n. Remember the think balloon. X to the n times x to the n is x2 in the think balloon, n plus n. X to the 2n. If you get confused, think of a think balloon. Remember, if I do x squared times x to the third, it's x to the fifth because my think balloon is 2 plus 3. So, think balloons, pretty helpful. All right, factors of the minus 3. I could use minus 3 and plus 1 or plus 3 and minus 1. I'm going with the plus 3 and the minus 1. And then I have to do my variable, y to the n, y to the n. And there we go. So, good luck with this homework assignment.